In this video series, we will be going over how to solve various trigonometric proof problems. In your pre-calculus class, your teacher may give you a trigonometric equation, such as this one, and ask you to prove it, or verify that one side is indeed equal to the other. In order to do this, you'll need to pick one side of the equation that you manipulate to show that it is equal to the other side. You can do this by substituting the various trigonometric identities I listed here to the side of the equation that you choose to manipulate to match the other. You may also need to use algebra skills that you have learned in the past to prove a problem. Now, let me show you what I mean in this example problem. When you are given a trigonometric proof problem, it will say something along the lines of, verify the following, and then list an equation such as this one. The first step you have to take is to pick a side of the equation that you want to manipulate to show that it is equal to the other. It is typically easier to manipulate the side of the equation that has the most stuff in it. So in this case, I will choose to manipulate the left side of the equation. Now, my end goal in this proof is to manipulate this part of the equation so that in the last step I have tan x plus cosecant x is equal to tan x plus cosecant x. So I basically want to transform this into tan x plus cosecant x. So now I'll show you how I would do this. When I look at the numerator of this problem, I see that I can turn these two variables right here into just one. If I look over at my trigonometric identities over here, I see that 1 minus cosine squared theta, or x for our purposes, is equal to sine squared theta, or x for our purposes. So, this equation is the same as sine squared x plus cosine x over sine x cosine x. Now, if I look at my angle of tan x plus cosecant x, I notice that there are two separate variables, whereas on my left side, there's just one large variable. So I'm going to separate it out into two variables so it looks more like my angle on the right side. I can use this algebraic property that I know to separate it out. It is a plus b over c is equal to a over c plus b over c. It can help you to understand the reasoning of this property I have stated if you think about it with simple numbers. For example, 1 plus 2 over 5 is equal to 1 over 5 plus 2 over 5. So now, let's write our equation separated out like this. Sine squared x will be a, cosine x will be b, and sine x cosine x will be c. So now, let's write our equation like this. So, sine squared x over our denominator, sine x cosine x plus our cosine x over the denominator, sine x cosine x will equal that. Now, you may notice that we have like terms that can be canceled out in the numerator and denominator of these two variables. We can cancel out a sine x from this variable and a cosine x from this variable. I'll show this on another line to make it clear. So, sine squared x is equal to sine x times sine x. And now I'll bring down the rest of the problem. So that will be over sine x cosine x like it was before. And then we can leave this part the same, so cosine x over sine x cosine x. So now, as you can see, we can cancel out a sine x from this part and on this variable a cosine x. So that leaves us with sine x over cosine x that we brought down from there, plus this was canceled out, so it's just 1, because you could times 1 in the numerator, over sine x. And if we look at our trigonometric identities, we can see that sine x over cosine x is equal to tangent x. So this part is equal to tangent x. And we see that 1 over sine x is equal to cosecant x. So this is the same as cosecant x. Now we can bring down the right side of our equation, which is the tan x plus cosecant x. And we have finished our proof because the left side is equal to the right side. So we are all done solving this trigonometric proof problem. If you found this video helpful, please go ahead and hit the like button. And also, please subscribe to my channel if you haven't already. And as always, thanks for watching.